Bro.
Hi everyone, my name is Jeremy Sakraj Lazarus and my student number is S4131283.
Hello everyone. My name is Samir Khan and my student number is S4137477.
Today, my teammate Samir Khan and I will demonstrate the proactive thread hunting process we completed using the Suricata event log file called revised q4 ev.json. The first step was to verify that the event log file was successfully imported into Kali Linux. We checked the file location and size to make sure it was available for analysis. Next, we verified that the JQ utility was installed. Since the Suricata logs are stored in JSON format, JQ was used to filter and analyze the data efficiently. After that, we analyzed the log file to determine the total number of alerts. The result showed 100,000 alerts, indicating a high level of security activity within the monitored environment. We then examined the different alert categories to understand the types of threat present. Some of the major alerts included MongoDB credential guessing attack, Redis configuration abuse attempts, Nmap scanning activity, MongoDB port scanning, suspicious large data transfer, and attack response alert. These alerts suggested that attackers were performing activities scanning for vulnerabilities and attempting to gain unauthorized access to database service. Based on these findings, we formed a threat hunting hypothesis that the database environment was being actively targeted and required further investigation. To validate this hypothesis, we continued analyzing the logs to identify suspicious source and attack related activity. I will now hand over to my teammate Samir Khan to explaining the remaining findings.
Thank you, Jeremy. Um, to continue the investigation, we analyzed the source system responsible for generating the highest number of alerts. We found that a small number of systems were responsible for a significant portion of the suspicious activity observed in the logs. This behavior is commonly associated with reconnaissance vulnerability, scanning, and attempting exploitation of network service. Next, we filtered attack-related events from Suricata logs. The results revealed multiple attack response, alert, and scanning activities targeting the environment. These findings indicated the attackers were actively probing the system and attempting to identify weakness. We then focused specifically on the database server and found that it was repeatedly targeted by multiple security events. Several alerts were associated with this server, including session traversals attacks, response events. These confirmed our hypothesis that the database server was a primary target within the environment. Finally, we analyzed the repeated attack source and observed that certain systems appeared consistently through the logs. This suggests ongoing and persistent attack behavior rather than isolated incident. In conclusion, our proactive threat hunting investigation successfully identified evidence of database related attack, including credential guessing attempts and vulnerability scanning, reconnaissance activities, and suspicious data transfer behavior. These findings demonstrate the importance of proactive monitoring and threat hunting in identifying potential threats before they cause significant damage to an organization. Thank you for watching our presentation.